So let's talk about how to make a light curve. I'm going to do this pretty quick and dirty and not edit it, but the goal is to make a light curve that looks or has the characteristics that this one has here. Notice that we've got an object up here in the title, and on the vertical axis, one thing to notice is, look, it says 16 down here and it says 14 up here, and then down here we've got these big numbers that are dates, modified Julian dates. So let's talk about how to do this. First, we're going to want to know what source are we working with. Here's some sample data I just set up here, and our catalog may or may not look exactly like this, but the rough idea here is like right here. You can see we've got the name of a source. This is a source definition from URSA that basically is a location. Right here are right ascension and declination values. Remember, right ascension and declination, RA and dec, refer to basically longitude and latitude on the sky. Over here we've got values that aren't that important to us, but this is how bright the thing is in magnitudes and in the WISE 1 channel and the WISE 2 channel. I'm going to skip over that. And then here's some other annotations which aren't important to us now but might be important later. One is this in the north CVZ or the south CVZ, and how far is it in arc seconds from the pole? None of those things really matter right now. What we want is this. Ordinarily, you'd have to grab the RA and dec and get them separately. This sheet happily has a little thing which is them together with a comma that makes it easy. So I'm going to go copy, and I am going to now go and get that information. Zoom back out here. So I'm going to go to my browser, and I'm going to go to URSA. And now we need to go, where am I going to get this info from? So I'm going to go to catalogs. You could go straight to WISE, but I'm just going to do this. I'm going to go to catalogs. Which catalogs do I want? Well, I want the WISE catalogs. I'm going to select the WISE NeoWISE catalogs. And now here, there are a lot of WISE catalogs. What I want is the catalog of, not of all the points on the sky, but I want the catalog of all the points identified in each image ever taken. So that goes down here in this second selection, NeoWISE R single exposure source table. I want the single exposure source table. So I'm going to select that and open it. So here we are in the single exposure source table, and I'm going to go right here where it says coordinate or object name. I'm going to paste my coordinates. That's my RA and dec. And this says single object search. I'm only interested in one thing. Down here, I'm going to change this to 5 arc seconds. I want a big enough area around my object so that I can see what's right nearby in case there's anything impinging on the field of view that could have an effect on our data. But I don't want it so big that it's got a bunch of other things I don't care about. So I'm going to say 5 arc seconds. Now, in practice, later on, you would want to put some additional constraints in down here. All right, that essentially says, hey, give me only the things that we think are really high quality. We're going to save that for later. So this is just the basics. So here, I'm going to do that. I'm going to click Run Query. So I run the query. Now, this may take 10 seconds. This could take more. You just don't know. You don't know how busy the server is. There could be, a bunch of other people who are querying the server and keeping it really busy. You might have asked for something that is hard to sort. In my experience, it's usually more than 15 seconds, less than a minute, but you just never know. So we're waiting. If it takes a really long time, this screen will change and basically say like, hey, it's going to be a while. And you just kind of keep your eyes out. But in the way I do it, I don't usually touch this. While it's running, I will mention, just preview, not going to deal with it now, but there are other ways to get this data. There are ways to ask Topcat to directly go out and query the database for you. But we're going to start here using the catalog interface on the web, just so you get familiar with what URSA looks like. Okay, here we are. Here is our return. So a couple of things to look at here. First thing to notice is that there are 3 big windows. There's this window here that looks like a picture. There's this window here that looks like a graph. And down here, there's a window that looks like a table. Ultimately, all we really care about is the table. We'll come back to that in a sec. But for the moment, it's a great idea to have a look at this image. So there's some way to pop this out. Here we go. So I'm going to make the image bigger, and I'm just going to have a look here, and I may zoom in just a little bit. And that red spot is actually a collection of a very large number of dots, like tens of thousands of dots. We'll see how many in just a sec, which are the locations of our object of choice in many, many, many tens of thousands of different images that have been taken of the sky in this area. But notice this is essentially what the stacked up images would look like in the neighborhood. And the reason I'm showing this is that if there's something really nearby, that's important to notice. Notice that there's really nothing else in the neighborhood here. We really don't have to worry about this being crowded, about the measurements here being confused by measurements of some other object. That's good news. So I'm going to close this up somehow. Close. And I'm going to skip talking about this graph because we're going to make one of our own just for the heck of it. All right, so we're going to go down here. What you want is you want to download the data. How much data is it? Look up here. 34,793 sources found. Now, that's 35,000 sources found in 35,000 images. Our hope, and we've got reason to believe it is that these are all from one source. But what it says is 35,000 sources found. We're gonna download this data. Now you got to be careful here. If you're like hover over this and it goes like download and save this. Notice it says save this chart. You don't want to get the chart. You want the data. So I'm going to go down here, full results table. Hey, they're only showing me 100. I don't want to see all. I just want to get them. So I'm going to hover over this thing that's supposed to look like a floppy disk, and you probably don't know what that is unless you're over a certain age. It says save the table. I'm going to click on that. And this is going to come down in a format that nobody else uses, an IPAC table, a .tbl. And here's going to be the file name. Now, I'm thinking, just to be really careful, I'm going to because maybe I might download a couple of things and I want to know which data set is which, I'm going to go here and I'm going, oh, what is this? I'm going to say IRMA candidate 1. So I'm going to go IRMA candidate 1. I'm going to give, so when it comes down, otherwise it's just as like IPAC table. I'm going to save this. And I'm saving it to my computer. So I should be able to go over here and be like, hey, show me the downloads. And so right up here, we've got a file that says IRMA cand 1. So that's mine. It's a .tbl. It's not small, right? It's okay. It's almost 15 megabytes. So now I'm going to go to TopCat. And in TopCat, this is the control window for TopCat. Lots of other windows are going to open up. And TopCat is basically a tool for working with really big tables, or for working in helpful ways with multiple tables. So I'm going to open this thing up in TopCat. I'm going to go over here to the little file folder thing. I'm going to click on there. And I'm going to say, the first thing, this is not like other documents where you're just like, oh, I have this data, I'm going to double click on it and open it. No, don't do that, because it'll try to open in like a text editor. So we need to go into TopCat. Also, TopCat accesses all kinds of files, and sometimes TopCat can be smart and be automatic, sometimes it can't. So it's a good idea to tell TopCat what kind of file you're opening. Whoa, there's lots. I'm going to go down here, look, there's an IPAC table. So I'm going to open an IPAC table, and I'm going to find it by going into my system browser. And oh, look, there it is. So boom, open. All right, so here's the control window, and it's telling me that one of the tables that I have access to now is my IRMA candidate 1. IRMA candidate 1. And the first thing I want to do, and you don't always have to do this, but I'm going to do it because like we already looked at the image, so we know there isn't a lot of junk, but I'm going to do this anyway. I'm going to make a sky plot. So These buttons up here, really useful. If you hover, you'll get little text. The thing, it says sky plotting window. Boom, I'm going to open the sky plotting window. And the sky plotting window is automatically built to plot positions. Notice what we have on the vertical axis is our declination. Notice that even though it has come in probably in decimal degrees, that TopCat has translated this into degrees, minutes, seconds. Also on the horizontal, the right ascension, this has been translated into sexagesimal. So this is in hours, minutes, seconds. Do you have to manage that? You don't. But when you look at it, you don't want to freak out. You want to be like, oh yeah, that's just, degrees of right ascension converted into hours, minutes, seconds. So the important thing about making this is every single one of these dots is the measured location of our target in a different image that was taken over the course of perhaps 14 years. We would say this is really good. And the reason it's really good is this looks like a point source. The telescope is going to come back tens of thousands of times and image the same thing. And the telescope may jiggle around a little bit. It may not have its orientation perfectly measured, right? There's always a little bit of uncertainty in every single measurement. And so the telescope takes a picture of the sky, and when it takes a picture of the sky, it records with that picture, this is the direction I was pointing. But that could be off by tiny little bits. Later on, the pipeline is going to look at that dot in the image. It's going to take the information that the telescope recorded, this is the way I was pointing, and figure out where every single dot is on the image and be like, okay, this dot corresponds to these coordinates on the sky. So notice that they all clump really well together in the middle, and then they spread out kind of. But the biggest spread here, we're talking about differences of, 1 to 2 seconds, where almost everything is right here in the middle. So this is a point source. This is not a problematic source. Maybe we'll see problematic ones later. This is not what we came to do here, though. So I'm going to close up this sky plot. Don't need it anymore. And what I'm going to do is I'm going to make a plane plot. This is where I'm going to make my light curve. So I'm going to open up the plane plotting window, and I'm going to make this window really big. Now, this looks a lot like what I had before, and that's because by default, this is just going to look at the first 2 columns in the table, which happen to be RA and DEC. But that's not what we're going to do with this. Before we go on, I'm just going to point out a couple of things. I've made this big because I'm going to want a big table. And then the other thing is that sometimes, like your controls are all down here, and your graph is all up here, and sometimes things get cramped. This button over here lets you pop the controls out into a separate window. I like to work this way. Some people don't like to work this way. I like it because then I can make the control window big, because often there are a lot of controls to see here, and I can move it around and still see. Some people like to keep it attached. Up to you. So things to notice in the control window. There's a bunch of buttons for essentially adding features to your plot. Then in this column, there's the things that you want to control. And right now, what I have selected is a particular data set. So if I uncheck it, it goes away. This is helpful when you're plotting more than one data set. But so I've got like, what data set am I working with? What's visible on the plot? And then up here, what are the different things I want to control? So the first thing I'm going to do is I'm going to say, I want to know how bright my object was over time. So on the x-axis, I'm going to put time. Time is MJD. MJD. Where are you, MJD? Well, I can't find it, unfortunately. You can go hunting for it, but I happen to know it's MJD. MJD, modified Julian date. Okay, so now on the horizontal, I have MJD, modified Julian date. On the vertical, I have the declination. So this isn't very interesting. This is now a plot of what's the declination of these objects over time. On the Y, I'm now going to say, I want to know how bright my thing was in the WISE1 channel. W1 M pro, which is M is magnitudes and pro is like how, anyway, W1 M pro. I can just type this in, or I can select W1 M pro. All right, so there's my plot of brightness over time. I'm going to do a few more things. One thing I'm going to do is I'm going to look at this axis here, and I'm going to say, wait a minute, when we're plotting magnitudes, I want the small numbers up top, because small numbers mean bright. Big numbers mean dim. So I'm going to go here to the axes, and I'm going to say, I want the y-axis flipped. I'm going to click Y flip. So now, hey, look. Now I've got my small numbers at the top, my big numbers at the bottom. Let's see, is there anything else I need to do right away? So the next thing I'm going to do is, so this is what my object looks like in Y's 1 channel. I'm going to add also a plot for what's going in Y's 2. So I'm going to, up here with the buttons, there's a thing that's like a little plus and a bunch of dots. It says, I want to add another, it says add a new positional plot control. So it's like another thing that's saying where to put points on my plot. So I'm going to click this thing. I have to tell it which table. Why do I have to do that? Because I might have lots of tables here. So I need to tell it which table. So I'm going to say, oh yeah, I want IRMA candidate 1. And I don't want XVRA and DEC. I want this to be, and this time, instead of pulling down, I'm just going to go, I know, MJD, and in Y, I want W. But now I want to know where are we in this Y's 2 channel, W2 M Pro. Boom. Okay. Now we're getting somewhere. Now, why are they all crammed down here? Well, all these guys are crammed down here because this is made, Topcat's made decisions about scaling, and we've got all these weird outliers up here. Now, if I have 35,000 points, and there's like 12 that are up at crazy locations, I do not care about those 12. So I'm going to change the scale here so it shows the great bulk of my points. So I'm going to go back to my axes, and now first time it was in axes and we had like coordinate controls. There's a bunch of other things here. I'm going to go to the range in the axes, and I'm going to say that I want my y, and I always get confused here whether minimum means minimum numerically or minimum bottom of the thing. We'll just try. I'm going to say I want the smallest value of y to be, I don't know, I'm going to try 13. Aha. So now we're getting a better look, right? I can't see a lot of the outliers. Well, let's stick with 13 for the moment. Okay, so I'm gonna, you know what? So I'm gonna click this button just to hide that again so I can see my light curve. So here's my light curve. Now, the problem is, this thing is fuzzy. Why? There's an enormous amount of noise, right? These points vary all over the place. I can do a couple of things to make it clearer what's going on. So the first thing I'm going to do is I'm going to go to this data set. I'm going to go to, so basically I'm saying plot number 1 is my Y's 1. And I'm going to go over here to form, and I'm going to say, so remember, this is 35,000 dots all over each other, and so when they just stack up, it just starts to look like thick paint. I can't remember which one it is. I'm going to try transparent. Yeah, so notice that's a little better. So like where there's only one dot, it looks kind of pale, but where there's a bunch of dots, it looks thicker. I like that. So I'm going to do transparent for both of these. So this is in, and all right, so this just helps me see what's going on. But it's still pretty fuzzy. So the next thing I'm going to do is what's called binning the data. I'm going to bin the data. I'm going to say, listen, don't show me every point. Well, I mean, do show me every point. But I want to draw a line that instead of showing me every point, tells me what's going on in any small chunk of time. So we could say, in a day, what mostly was going on during that day. Now, from experience, A day is a little bit too short. You can experiment this and see. I'm going to say I would suggest starting with 5 or 10 days. So what we're going to do is this. We're going to ask, Topcat does not have an automatic binning function. There is software that has automatic binning functions. We're not working with that. So what we're going to do is we're going to say, hey, Topcat, we're going to kind of trick it. We're going to say, hey, Topcat, make a histogram for us. But instead of saying like, oh, how many points have this particular value, we're going to say like, in this range of time, give us the median value, So that's going to make it so that the outliers don't matter. They don't pull our average one way or another. So here's how we're going to do the binning of the data. I'm going to go over here and back to my buttons. And actually, I'm going to pop this out again because we're going to get a lot of controls for binning the data. So popping this out, and up here, there's a thing that's like add a new, what's it say? Add a new optionally weighted histogram plot control. So we've got controls for our W1, our W2, and I'm going to go here and we're going to add a histogram. We have to tell it what table. It's our candidate 1. Then we have to say what we want on the X. We want MJD on the X. And on the Y, we want W1M Pro. But, right, this is not helpful so far. But here's where we get sneaky. We're going to go to the form, and we're going to say the following. We're going to say, first of all, don't combine up all these values by adding them up as a sum. Do this. Take the median. Okay, so now I get a median. And then the other thing is, don't show me a bar. Like, that doesn't help me. I want to know actually where we are. So instead of the bar form being semi-filled, I'm going to say show it to me as steps. Steps have problems too. When there's gaps, we get these weird spikes, but we'll live for a moment. Here's also where you would control if you want to change its color and stuff. But here is next tricky thing. It says bin size. So right now, it's basically saying, oh, I'm getting the median every 100 days. That's a little bit much for me. So I'm going to do that. In my experience, this slider is really useless. It's just hard to use. So I'm just going to type in numbers here. So I'm going to go every 5 days. Okay, let's just have a look at what happened because of that. So now we've got, this looks kind of jagged, but every 5 days is like a flat little point. And what this allows us to do, I'm going to shrink this up again, is get a better way to eyeball what's happening inside this curve. So like there's just like this little up bow right here that probably takes several years. And then there's just this noisy, staggery up and down, up and down. It kind of gets more stable. And then we get these jaggedy bits over here. These crazy spikes here, those crazy spikes are meaningless. That's just, what that means is, oh, there's some places where we have no data. And so it's reading a 0, but because it's trying to make this histogram, it like jumps all the way to 0, which is at the top. We don't care. So this is a binned data. I'm going to change that bin size just to see what happens here. I'm going to change that bin size to 10. That should smooth this out a little bit. Gives us less detail, but we're basically saying, show me what happens every 10 days. And now it doesn't look quite so jaggedy, right? It doesn't look quite so jaggedy. Your call what to do here. Our job right now is just to be able to assess these graphs by eyeball. So now I've binned the W1 data, and I'm going to also bin the W2 data. So I'm going to make another histogram plot. Boom. Here's my table. This is going to be MJD, and the weight is going to be W2M Pro. And now I'm going to go to the form, and I'm going to say, don't make that the sum, make that the median, and make this steps, and make this, I left that one at 10, so I'll leave this one at 10. So now we've got that gray on blue, that's kind of hard to read. Let's not talk about subsets, but I should be, so now it's turned red. So, and I could control that color here. It'd be like, I want it blue on blue. That's hard to read, but you can fool with this. Well, now they're both green. That's good. So now I'm going to just shrink that up. So here's my light curve. This is pretty great. You have a light curve. Two tiny detail-y things before we go that are just good housekeeping. So thing number one, and I'm gonna pop this out again. Thing number one is ideally we would have a legend that would show us what is working here. So ideally I'm gonna have a legend. So I gotta remember how to do this. I'm gonna go to the legend. Yes, I wanna show the legend. Yeah, I want it opaque. I don't know why I like it inside. I want like it internal. Oh, now it's on my plot. And then you can just be like, oh, where do you like it? You know, you want it down at the bottom. And right now, that legend is not helping us a lot because it just says all. So now we're going to do this one other thing, which is I'm going to go back to, so here are my different controls. So here's my W1. I'm not going to explain subsets right now, but essentially what we want to do is we want to give this a link. Right now when it's saying all, it's saying I am plotting all of this data. So what I want to do is I'm going to just give this a name. I'm going to say this is my W1 data. And notice that now the red dot has changed to W1. And I'm going to do the same thing here. I'm going to call the second one W2. And then just to be really thorough, I'm going to call this W1 binned 10 days. And then I'm going to go W2 binned 10 days. If you're in a rush and you're just having a quick look at the data, this is not crucial. But if you're going to save this graph for looking at later, and you're going to look at this graph, you know, a couple of weeks from now, a couple of months from now, the more information, the better. So the last thing that I'm going to do is I'm going to go here. Ooh, I think it's in axes. Labels, nope. Frame, no. I want to put a title on this darn thing. Title, that's silly. Frame, title. And I'm going to say the plot title. And so I happen to know what source this is. This is, I'm going to call this practice Irma source 1. So now I'm going to end up with that on my graph. So if I save this graph and look at it later, I'm going to have that. Now, Topcat is not like a word processor or a spreadsheet or something or other. This is not a document. You've just like manipulated and looked at some tables, and we're not editing the table. If you want to save this graph, it's not like just click save. What you need to do is export the graph as something. So I'm going to go in my plot window. I'm going to go up here, and it's this funny, I don't know why it's shaped like this, but it says save the plot. So I would save the plot. I would give it, I would be like Irma practice source. I'm going to go Irma practice source 1, and then I would say, what file format do I want? A PNG, whatever, pick. PNG is a pretty reliable one. So, and then you direct it where you want it. I'm going to put in my downloads, whatever, and then you would hit export. And now you should have a PNG somewhere that looks like this. You've created that. I can close up my plain plot, last thing before I go. But if I'm going to make more than one light curve, there's a huge shortcut, because I have essentially built all the directions for how to make this plot into this window. And if I wanted to look at a different data set, all I'd have to do is say, oh, for this plot control, right here, I've said in position, hey, control the red dots by looking at this table, Irma candidate 1. But if I go now and download another candidate, and I call it Irma candidate 2, and then I say, oh, just point this to Irma candidate 2, and then make the other one look at Irma candidate 2, I'm going to get a whole new plot. The one thing you'll have to fix is like the histograms get wonky. Like for some reason, I don't understand when you change the table on the histograms, like all the settings go. So you do have to go back there and be like, no, I want a 10-day bin or whatever. But you can save yourself a ton of time because you can download 5 data sets, make the light curve for one, and then just save that and then change the table you're looking at. Now you've got another light curve. Change the table you're looking at. Now you've got another light curve. That's how to make a light curve using Topcat. Oh, and the last thing to say is At this point, like there's nothing, I mentioned there's nothing to save or quit. I'm going to close this plane plot. It only throws out my like control work. Boom, I'm done. If, nothing I am doing influences the underlying data. So I can just quit out of TopCat and it's not like it has some effect on my data. Okay, that's it. That's how to do it.